first theorem we're going to have a look at proving is theorem 4, which is that the angles in any triangle add to 180 degrees. So the whole point about proving a theorem is that you could take loads of different triangles and add up their angles, and you know, some of the time we get 178, some of the time we get 181. But in proving the theorem, what you're doing is you're showing that in any triangle you draw, if you draw it accurately enough, the three angles should always add to 180. I suppose the point is, no matter how many you draw, it doesn't tell you that the next one definitely has to add to 180, whereas proving a theorem kind of shows you that no matter what you do, as long as you do it accurately, as long as you draw it accurately and measure it accurately, then your angle should add to 180. So we have the same kind of structure the whole time. First of all, with the theorem, which we're given, which is that the angles in any triangle add to 180. First thing we always do is we draw a diagram. Alright, so we're going to draw a triangle. So in order to follow what you have, if you're following this in the book, we look at A, B and C. Let's call that A, B and C there. Let's call this angle 1. Let's call this angle 2. Let's call this angle 3. And often when you're doing these, if you're going to use angles a lot, give them numbers, because it makes it a lot easier when you're writing out the proof. Rather than saying the angle ABC, we can just say the angle 2. Alright, so that's the diagram. The next thing we write down is we write down what we are given. And this is so that you kind of keep it clear in your head between what have we been given and then what we actually go and prove. So we're given a triangle ABC with angles 1, 2, 3. That's what we're given. To prove, so what do we want to prove? Well, we want to prove that 1 plus 2 plus 3 add to 180. And remember we said there's notation for this, so this sign here means the angle 1, and the two lines mean the size of the angle 1. So the size of the angle 1 plus the size of the angle 2 plus the size of the angle 3 equals 180 degrees. You need to write in this line to show that you're talking about an angle. You need to do the two lines to show that you're talking about the size of the angle. Alright, so that's to prove, and the most important bit in most of the proofs that we have is the construction. The construction is where the idea for the proof is contained. So the construction here, this is the trick to remember, is we draw a line through A parallel to BC. Alright, now we could if we want, so let's just do that in. So we draw a line like this through A parallel to BC. If we wanted to, we could have drawn a line through B parallel to AC, or we could have drawn a line through C parallel to AB. It doesn't really make a difference. We're just going to do this one because it's easier to draw in here. And we're going to mark in the angles 4 and 5. So this is angle number 4 and this is angle number 5. Alright, so that's the construction. So let's just write that down. So draw a line through A parallel to BC. Alright, and we're going to mark the angles 4 and 5. Mark angles 4 and 5. Okay, so the proof now is going to proceed as follows. What we do is we show that this angle is equal to this one because they're alternate angles. Alright, this line is parallel to this line. This line cuts through them, so this and this are alternate angles. In the same way, 3 and 5 are alternate angles, so they're the same as well. So 2 equals 4 and 3 equals 5. And then the one thing that we know about this kind of an angle is that it adds to 180 degrees. So 4 and 1 and 5 equals 180 degrees. So that means 2 and 1 and 3 equals 180, because 4 is the same as 2 and 5 is the same as 3. Alright, so we're going to do that. So we get a new page for that. So this is the proof. Usually if you can remember the construction, the proof won't be a problem. So the proof says the angle 2, the measure of the angle 2 is equal to the measure of the angle 4. And you always have to give a reason. So the reason we give here is that they're alternate angles. Okay, so 2 and 4 are alternate angles. And then 3 is also equal to 5. And again, because they are alternate angles. Okay, so the third bit then was saying, if you remember, so 2 equals 4 and 3 equals 5. So now 4 and 1 and 5 add to 180. So therefore 2 and 1 and 3 add to 180. Alright, we replace 4 with 2, which is the same as. We replace 5 with 3, which is the same as. So 2 and 1 and 3 add to 180. So 4 plus 1 plus 5 equals 180 degrees. And the reason for that is that that's called a straight angle. So a straight line like that is called a straight angle, and therefore 2 plus 1 plus 3 equals 180, and we're finished. Done. So the actual proof is only 4 lines long, the proof bit of it, but if you can remember what the construction is and what the trick is, you will have pretty much all the work done by the time you get to even starting the proof. Okay, you'll have pretty much all the work done. And just to say one more time, the importance of proving something is that no matter how many triangles you go and draw, first of all, they won't all add to exactly 180. You're not sure then, is it because I didn't draw them right, or is it because it's some triangles, the angles don't add to 180. And then secondly, even if they did all add to 180, that doesn't mean that the next one is going to add to 180, or the one after that is going to add to 180. The nice thing about a proof is that it shows that this is always the case. If you draw a triangle accurately enough, and if you measure the angles accurately enough, then the 3 angles will have to add up to 180 degrees. So that's the end of the proof.